So in this example, we will discuss on uh, this circuit. So the circuit is actually quite similar to the previous example, but the difference is the circuit does not have a bypass capacitor across the RE. So this is unbypassed emitter RE. So same with the previous example. So we will do the analysis on the input impedance, output impedance, voltage gain, current gain, and power gain. Okay, so we assume VA as infinity, so R naught is also infinity, and then VC is 2.37 milliampere. So this means that GM is equal to 191.15 millisiemens, and based on this GM we can calculate the R pi is equal to 1.32 kilo ohm. So this calculation have been shown and have been explained in the previous example. Okay, so next we do the first analysis is we need to draw the equivalent circuit. So equivalent circuit, the drawing is from the input. So we have here, this is Vs, and then it's connected to the 600 ohm, and then C1 is short circuit. So we have here R1, because the VCC is grounded, so it become like this. And we also have here, this is R2. Okay, and then we come to the base of the BJT. Between base and emitter, we have here, this is R pi. The voltage across the R pi is V pi. Okay. At the emitter point, since there is no bypass capacitor, the RE will appear. So this is RE, and then we have, this is voltage dependent current source here. This is GM V pi. So R naught is infinity, so R naught can be removed. At the collector, we have RC and RL. So we have here, this is RC, and this is RL. So this is RC, this is RL. So this is the equivalent circuit. Okay, if you want to calculate the input impedance is here. So this is ZI. So ZI is equal to R1 parallel with R. Okay, R1 parallel with R2, and then parallel with this the resistor network defined by ZB. Okay, ZB is the resistance, equivalent resistance seen from the base. This is the base point. So this is ZB. Okay, so ZB. So we know that R1 and R2, the value is 8.2K, and R2 is 1.5K. ZB, okay, this value 8.2K and 1.5K, the parallel value is equal to 1.27 kilo ohm. So this is ZB. So how we can calculate the ZB? ZB is VB over IB. So ZB is VB over IB, and then the base current here. Okay, the base current is here. This is the base current. This is the base current. Sorry, this is the base current. Okay, how about the VB? VB is the voltage, the sum or the total of the voltage drop at the R pi and the voltage drop at the RE. So voltage drop at the R pi is we can use the vpi, but now we want to express it using the ib. So we use the ib times r pi. R pi here is we have calculated r pi is 1.32k. Okay, and then plus voltage drop at re. Re is 1k. This is ib, and this is ie 1k equal to ib. Okay, and then ie can be converted to ib using beta plus 1 ib. So this is become ib plus, okay, and then this is ib beta plus 1 is 1k equal to ib, and then you got this one is uh, so this is equal to 122.32k. Okay, this is ZB, and for the ZI is 1.27k parallel with 122.32k. So this calculation, so you should get around 2.6 kilo ohm. So this is the answer for the input impedance. Okay, for the output impedance, this is very simple, because when for the output impedance, we will consider the case where the supply is 0 or input is 0. So because supply is 0, the V pi is also 0, GMV pi is also 0. So the current source will not provide any current. So this is open circuit. So we will see only RC. So the Z out is equal to 4.3 kilo ohm. Okay, so this is the Z in and Z out. Okay, next we calculate the AV. AV, let's say we calculate AV and AVS. Before that, we need to I need to redraw the equivalent circuit. So this is the equivalent circuit. Yeah, this is RL, this is RC, the current source is GMV pi, and this is RE, this is R pi, this is V pi, this is R2, R1, and then this is 600. So this is VS. Okay, the AV is, let's calculate the AV. AV is defined by the voltage across the RL over the Vin. Vin is the input voltage. It's not Vs, so Vin. So here the calculation of V out. So how you can calculate the V out? For calculate the AV, you need to derive the V out and V in equation. So V out is this current direction. The direction, the current value that across this RC and RL current network is minus GMV pi. This is minus GMV pi. So V out is minus GMV pi times the combination of RC and RL. So RC parallel with RL. So we insert the value. So we have V pi, RC is 4.3k, RL is 10k. So you got this one is RC and RL is 3k. We have calculated this one. So okay, the calculation here. So 91.15 times 3. So you got this one is minus 273.45 V pi. Okay. Then how about the VI? Okay, VI is from this point with respect to the ground. So this point is equal to the VB. So VI is equal to VB. So VI is actually equal to uh, IB ZB. Yeah, VI is equal to IB ZB. Okay, and then the ZB we know the equation for the ZB. The ZB, the equation is sorry, the value of the ZB is 122.32 K. So this is IB 122.32 K. Okay, and then what is IB? So IB uh, can be expressed as a function of V pi. IB is V pi over R pi. So this is V pi over R pi is 1.32 K. Okay, from these three equation, so you got the AV is equal to minus 273.45 V pi over 122.32 K. Okay, and then divide times V pi over 1.32 K. So this is K is cancel out. So the calculation is 273.45 times 1.32 and then divide by 122.32. Oh, sorry, 122.32. So you got the AV is minus 2.95. Okay, if you see here, the value is very small compared to the one with the bypass. So the unbypass has lower gain. Okay, so this is the conclusion that we can make. Okay. If you want to calculate the AVS, okay, AVS, you can calculate the AVS using there is many approach. So actually AVS is V out over Vs. So this can also be arranged as V out over V in times V in over Vs. And then you know V out over V in is AV. So AV VI over Vs. Okay. So VI over Vs can be derived from the relationship between the input voltage with the supply. So this is voltage divider. VI is equal to input impedance Zi. This is Zi plus Rs Vs. So this is the Zi is 1.26 K, and then this is 1.26 K plus Rs is 600. So Vs. So now you got the Vi over Vs is equal to 1.26 over 1.86. So you got here is 0.677. So thus your AVS is equal to minus 2.95 times 0.677. So 0.677 times 2.95. So this is minus 1.997. So this is almost 2. So this is answer for the AVS. Okay, so we can also calculate the AI. So let's calculate the AI. So before that, for a better view, we need to redraw the equivalent circuit. So we have this one is 600 R1, R2, R pi, and then we have the RE. This is RE. Oh, sorry. So this is not in it. This is RL. This is RC. And this is RE, CMV pi, R pi, C pi. Okay. So let's say I want to calculate the AI. So AI here is the current gain. So the current gain is defined by IL over II. So IL is the current across the load. So this if we consider the current source will provide the opposite current, which is here. This is in this direction. This is negative GM V pi. So IL can be calculated using the voltage division, current division. So IL is RC, so 4.3K. So RC is 4.3K. RL is 10K. So over 4.3K plus 10K minus GMV pi. So GM is 19.115. So you can calculate this one. 4.3 times GM is 91.15 milli. Okay, and then divide by 14.3. So you got this one is minus 27.41 milli. Then we have the V pi. Okay. And then for the II is the current inside the loop the input port. So II is ZI over V ZI over V sorry this is wrong. Z okay, II is equal to VI over ZI. Okay, II is VI over ZI. Okay, so for this one, so you know the value of ZI. Okay, the ZI is what's the value of ZI? 1.26K. So ZI is 1.26K, but the VI you don't have the value for the VI. 1.26K and then VI. So how we can calculate the VI? Okay, the calculation of VI. Okay, the VI is actually equal to VB. Okay, actually equal to VB over 1.26K. Okay, I would like to emphasize here there are a lot of calculation way how you can solve this question, but let me explain my way, and then if you find another simple way, more simpler way, so you can use your approach or your calculation flow. Okay, so for this, you see the VB is VI is equal to VB because VI is here and VB is here. So sorry, this is VI. So this is in the same node. So VB can be related with the ZB. VB is equal to IB ZB. So IB, this is IB ZB 1.26K. So and then the ZB is, we have the value of the ZB. The ZB is 122. Have the value here. And the ZB is 122.32. 122.32K over 1.26K. So you have this 122.32 over 1.26. So you got this one is 97.08 IB. Okay, so you have this equation. And then next, for you notice that the IL is as a function of V pi, and the II is a function of IB. So you can convert the V pi into the IB using the V pi is equal to IB R pi. So this is IB 1.32K. Okay, from these three equations, so you can get the value of AI. IL is minus 27.41 milli, and then we have here the V pi. V pi is equal to IB 1.32K over II is 97.08 IB. So now IB can be cancelled out. So the answer for this is 27.41 times 1.32 divided by 97.08. So you got the value of AI is minus 0.37. Okay. So the current gain is also decreased significantly. So this means that without the bypass capacitor at the RE, so the current gain and voltage gain decrease. So if you have already get the AI, you can also get the AIS. Okay, so AIS is equal to, for this equation, AIS is IL over IS. Okay, again, if you want to calculate the AIS, you need to convert this VS, the voltage source, into the current source. Okay. Anyway, IL over IS can be rearranged into IL over II times II over IS. So IL over II here is AI. So AI times II over IS. So what is I over IS? The relationship between I over IS is can be you can obtain that from the current division. So II is equal to RS over RS plus Z in. So this is IS. So II over IS is equal to RS is 600. So this is 600 plus 647. So this, oh sorry, the input impedance different. from the so the Z in is 1.26. Okay, 1.26K. So this one is 0.6 over 1.86. So this is 0.322. Okay, so the calculation is of IS is minus 0.37 times 0.322. So you got around minus 0.12. So this is the gain.